Good afternoon everyone. Myself Samaresh Pratap Mohanty, Department of Mechanical Engineering, Assistant Professor at Vedang Institute of Technology. So today we will study about and cover up the first module of the fluid mechanics. Then first comes to what is fluid mechanics. First, fluid mechanics. Fluid mechanics. It consists of two words, okay? Fluid and mechanics. Fluid means any substance which can flow. Mechanics means study of analysis of and effect of forces. Fluid mechanics we consider and we already know that Leonardo da Vinci is known as the father of fluid mechanics. He is a famous Russian scientist. Okay. What is fluid? Any substance which has a tendency to flow. Any substance which has a tendency to flow. In this, what is substance and what is flow? Substance is of three types. Okay. It is of three types, that your solid, liquid and gas. Generally, liquid and gas considered as fluid, and fluid having certain mass, it acquire vessel space. Okay. Then comes to the properties of fluid. Properties. Properties. First comes density. First comes density. What is density? Density is the ratio between your mass to the volume of the fluid. Okay. Mass of the fluid, mass of fluid, mass of fluid to the volume of fluid. Volume of fluid. Mass is, we know that m, volume is v. Mathematically, density denoted by rho. Rho is equals to m by v. This is the formula for density. Its unit is, as you know that mass unit is kg, volume unit is meter cube. Okay. So density unit is kg per meter cube. For water, rho is equals to 1000 kg per meter cube. Generally, we consider it. Then first density, then comes to weight density. Weight density. Weight density, known as small w. It is the ratio between weight of the fluid to the volume of the fluid. Volume of the fluid. Weight w, volume v. We know that w is equals to mg, mass into acceleration due to gravity. Then put down this mass into acceleration due to gravity by v. Previous we know that what, rho is equals to m by v. Then your m by v term becomes what, rho. Rho g. Weight density, then small w is equals to क्या what rho g. नेक्स्ट स्लाइड. वेट डेंसिटी के बाद आता है वेट डेंसिटी, देन थर्ड में आता है स्पेसिफिक ग्रेविटी. व्हाट इज स्पेसिफिक ग्रेविटी? Specific gravity, density of the fluid to the density of water. Generally, we consider specific gravity density of the fluid to the density of water. It is unitless. Okay, it is unitless quantity. As density divided upon density, then it is unitless quantity. Then comes viscosity. Viscosity or dynamic viscosity. It obeys Newton's law of viscosity. What is Newton's law of viscosity? Newton's law of viscosity means within elastic limit, the rate of shear strain is directly proportional to the rate of shear stress. Viscosity, tau directly proportional to du by dy. What is this? This is Newton's law of viscosity. Newton's law of viscosity. This is Newton's law. Mathematically, tau is equals to mu du by dy. This mu is known as what? Dynamic viscosity. It is the resistance offered by one layer of fluid to the adjacent layer of the fluid. Its unit is Newton meter per second square. Then comes to your kinematic viscosity. Kinematic viscosity. Kinematic viscosity. What is kinematic? It is the ratio between dynamic viscosity to the density of the fluid. Its unit is in SI meter per second, in CGS centimeter per second. Centimeter per second we known as 1 Stokes. The point to be remember, what? Centimeter per second is known as 1 Stokes. Then comes to your what? Surface tension. Tensile force acting on the one layer of liquid to the adjacent of layer of the liquid, there is small tension. Okay, but let us see. And for hollow bubble, it is most important. It is denoted by sigma. For hollow bubble, P equals to 8 sigma by d. For liquid drop, P is equals to 4 sigma by d. For liquid jet, liquid jet P is equals to 2 sigma divided by D. These are the most important formula for surface tension. Then comes to the your last part, what? Capillarity. Capillarity. What is capillarity? The phenomenon of rise or fall of a liquid when one layer of liquid is adjacent vertically merged to the another layer. Then know that the rise of liquid is known as capillary rise, the fall is known as capillary fall. Mathematically it is denoted by H. H equal to 4 sigma cos theta divided by what? Rho G D, where sigma is equal your surface tension and the angle inclination angle is theta, rho is your density, G is equal to acceleration due to gravity, D is equal to diameter. Okay. Let us solve some problem. Calculate the capillary rise in glass tube of 2.5 mm diameter when immersed vertically in a water surface. Tension of surface tension of water is 0.0725 Newton per meter. Surface tension for mercury given that 0.52. We have to calculate what is the capillary rise. Data given, solution. Given data is first for water. Given surface tension of water is 0.07. So, sigma is equals to 0.0725 given data. Diameter is equals to 2.5 mm converted into meter, 2.5 into 10 to the power minus 3 meter. Then for water, in the angle of contact not given, but we know that in a small tube the angle of contact is 0 degree for water. Okay. Theta is equals to 0 degree for small tube. H is equals to what? Your 4 sigma cos theta divided by rho G D. 4 into sigma 0.0725 divided by G is your acceleration due to gravity 9.81. Diameter is 2.5 into 10 to the power minus 3 meter and rho 1000. For water we know that 1000 kg per meter cube. Whenever we calculated this in a scientific calculator, we find the value of H is equal to 0.0118 meter. Okay. For mercury, H is your what? 4 sigma. Sigma value for mercury is 0.52. 0.52 divided by, for mercury D value what? Same 2.5 into 10 to the power minus 3. Given here 13.6, what? Rho value is 13.6. 13.6 into 9.81. and we find the value of h is equals to, यहाँ पर ओके cos थीटा का वैल्यू क्या है, cos थीटा का वैल्यू है 130 डिग्री, देन पुट cos थीटा इज इक्वल्स टू 130, h becomes 0.004 meter by calculating in a scientific calculator. Next, another problem. Question given, find the surface tension in a liquid jet, liquid drop and hollow bubble of 40 mm diameter when the inside pressure is 2.5 Newton per meter square. For solution, for data given here, what d is equals to 40 mm converted into meter, 40 into 10 to the power minus 3 meter. Surface tension 2.5 Newton per meter square. For hollow bubble first, for hollow bubble we know that what P is equals to 8 sigma divided by d, that implies that sigma is equals to P into d divided by 8. What is the value of P? P is your sorry, this is P. P 2.5 into d, 40 into 10 to the power 40 40 into 10 to the power minus 3, 2.5 into 40 into 10 to the power minus 3 divided by 8. Value will be 0.0125 meter whenever we calculated it in a scientific calculator. For liquid jet, surface tension is equals to P is equals to 2 sigma divided by d, that implies that sigma is equals to Pd by 2. Sigma is equals to P 2.5 d 40 into 10 to the power minus 3 divided by 2. The value will be, whenever we calculated, 0.005 meter. For hollow bubble, the surface tension is that. For liquid jet, surface tension is that, and for liquid jet, hollow bubble. For liquid drop, sigma is equals to Pd divided by 4, 2.5 into 40 into 10 to the power minus 3 divided by 4. Whenever we calculated in a scientific calculator, the value is 0.025 meter. We calculated the surface tension of a liquid jet, liquid drop and hollow bubble. This is all about first chapter of the fluid mechanics, some introduction parts and some numericals. Thank you.